Hey guys, so today we're looking at lesson 2.3, find the solutions of any quadratic equation. So as you know, if you were in Math 2, we've already worked with quadratic equations. So hopefully this section is a review for some of you guys. Alright, so find the solution of any quadratic equation. Alright, so solving quadratic equations can be done in many ways. You can factor, which you have previously learned. But what if the equation is not factorable? In this case, we still have three options. You can complete the square, we can use the quadratic formula. Finally, we can analyze the graph. We can also determine the number and type of solutions with the discriminant. So the discriminant is something we're going to look at too, which is also one of your vocabulary terms. Alright, so let's start by looking at completing the square. Alright, so the first thing I want to do is I'm going to pull up, and I like to be able to write out the process here so that you can see and kind of follow along with completing the square. Alright, so if we have negative x squared minus 6x minus 11 equals 0. The first thing we want to do is get rid of that negative, so we can multiply the whole equation by negative 1, and this becomes x squared plus 6x plus 11 equals 0. So negative times a negative becomes positive, negative times negative becomes positive, negative times negative becomes positive, and anything times 0 is still 0. So all we did was multiply by negative 1. Alright, now we need to subtract 11, because when we complete the square, we want to make this left side a perfect square trinomial. So we're going to have x squared plus 6x, and I always leave a blank here. You don't have to. When we're completing the square, it reminds me to fill in the blanks. But I'm going to subtract 11 to the other side, and then I'm going to add a blank here. So that forces me to do the same thing on both sides of the equation. Now, to complete the square, you're going to do half of b squared. Now, if you remember in a quadratic formula, the number in front of x squared is your a, the number in front of x is your b, and the constant is the c. So our b is 6. So if we take 6 and half it and then square it, that's going to give us 3 squared, which is 9. So we're going to add 9 to this side, and we're going to add 9 to the other side. Alright, so why do we do that? We call this completing the square because we have made this a perfect square trinomial now. Okay, so we can factor this as x plus 3 squared. Alright, so all we did was rewrite this in factored form, and negative 11 plus 9 is negative 2. And then we're going to take the square root of both sides. So x plus 3 equals, anytime we take the square root, there's an unknown, we're going to do plus or minus. And we know that a negative under the square root, the square root of negative 1 is I. So we're going to bring out the I, square root of 2. And then I'm going to subtract 3 from both sides. And x equals negative 3 plus or minus I square roots of 2. Okay, now that we've looked at how to solve that, and again, if you need to go back and refresh yourself, look up perfect square trinomials and you'll see how that refactored this. Alright, so the first thing says multiply by negative 1. So it already gives that here. And then it says subtract 11. So down here, this one will be the one that subtracted 11. So drag that there. And then add b over 2 squared to both sides. So that's when we add the 9 to both sides. which we did in this step right here. And then after that, you're going to factor. So have to be able to factor x squared plus 6x plus 9. So that's going to be this one. And then we take the square root of both sides. And then to simplify the square root, that's when you bring the I out. And then the last step would be to subtract 3 from both sides. Alright, so this just goes through the steps in the same way that I did over here. I just wanted to show you how that we would solve that before just dragging and dropping those into place. Alright, to use the quadratic formula. Alright, if you remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2. Alright, anytime you have a quadratic equation, the number in front of your x squared is the a term. The number in front of your x, that's your linear term, that's your b. And the number here, the constant, is your c value. So a comes from x squared, b comes from x, and the c is just the number. And all you have to do is substitute the values into the quadratic formula. Alright, to use the quadratic formula, we're first going to substitute the values in. So they've already identified 7, 13, and negative 5 as your a, b, and c. So we're going to take the quadratic formula, and the first thing we're going to do is see how they substituted that in. So negative b would be negative 13, so it has to be 1 of these second 2, plus or minus the square root of b squared, so 13 squared, so it's going to be that example right there, minus 4 times a, which is 7, times c, negative 5, over 2 times a is 7. Alright, then they're going to simplify that. So if you simplify the discriminant, which is the part under the square root, you're going to get negative 13 plus or minus square root of 309 over 14. So let me make sure, go through the process here. So if we have x equals, we have negative 13 plus or minus 13 squared minus 4 times 7 times negative 5 all over 2 times 7. Alright, so when you're working with the discriminant, you are simplifying what's underneath the square root. So you can see that 13 squared is 169. And you have 2 negatives out of 3 things being multiplied, so that makes that a positive. And then you've got your 4 times 7 times 5, and that equals 140. And then on the bottom you've got 2 times 7, which is 14. So x equals negative 13 plus or minus 169 plus 140 is the 309 over 14. So that's how we got this right here. Alright, this is very important here. If you are talking about the discriminant, the part under the square root, that is the part that tells you how many and what type of solutions you have. So if under the square root is positive, you're going to have 2 real solutions. That means if you look at the graph, their graph is going to be a parabola that turns up or down, but it crosses the x-axis twice. So it will cross the x twice, and that would be your two solutions. Alright, if it's negative, if the discriminant is negative, that means you have two complex or imaginary solutions, and that means your parabola does not intersect with the x-axis. So there are no real solutions in that case. Alright, if the discriminant is 0, that means if you look at the graph, it's going to come up and touch, and you're going to have one solution at the vertex. Okay? It could be facing up as well. And it doesn't have to be at the origin, but you're going to have one solution at the vertex. Alright, so this information here is all important and useful information. So make sure you take note of that. Alright, so it says use the graph and the discriminant to determine the number and type of solutions. Given the equation, use the discriminant to determine the number and type of solutions. Alright, so the discriminant is negative b, which would be b squared, negative 12 squared. So here's negative 12 squared minus 4 times a times c. So that's our correct answer. And then if we type that in our calculator or multiply that out, we're going to get 72. Because the discriminant is positive, the quadratic equation must have real solutions. The parabola that represents this equation must cross the x 2 times. Alright, so that's a little bit about the quadratic formula and completing the square. If you have any questions, please let me know.